So yesterday what we were trying to do, anybody remembers? It was very stressful for sure. And how stressful was that is what I'm trying to understand from you guys. Yes, Dikshita, tell me. What do you remember? What do you recall?
We learned about area of sector and like how to solve them and
No.
segment.
I was in the class. Yeah. What? Yeah, sure. Just give me a minute. Kids, just give me a minute. I just need to. Yeah. 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 Okay. No worries. Yeah. Okay. So we got some friends for Gayatri, and now Gayatri is more comfortable. And I was actually thinking that why some of the kids who were coming to the classroom have not come, and that made it little lonely for Gayatri. So now she has some friends with her, which is very nice. So what will I do is I'll just close the garage door so that I can turn on the AC. It makes you guys a little more comfortable. Gayatri, okay for you, sir? Okay, I think you were walking a bit slow. So yesterday whatever we did, sorry kids, I had a little bit of distraction, but I wanted to quickly call out what we learned yesterday was a bit stressful. Don't be shy, say yes, it's okay. It's okay. I want to hear facts loud and clear. So what we were trying to do yesterday, and I am going to peel off the onions, okay, today. I love cooking. So I'll peel off the onions first. Yes, Adrit.
So we were trying to figure out how to find the area for segments and how like to find the fraction of the circle and what
Okay.
there.
Correct. So let me narrate the story to everybody. So we have Vasundhara also now. She was also a victim of the stress yesterday. Where is Sulaim?
Here?
Where is Sandrine then? I can only see one hand. Is that Sandrine? Okay. Yeah, it's fine now. I was wondering where the kids are. Okay, now, so yesterday we were trying to learn the concept about how to find out the area of sector and segment of a circle. So I'll start from scratch and then I will pause it halfway through and then try decoding it one more time. This is a circle, and we all know circle has a very unique property that if this is my center of the circle, every point on the perimeter has same distance with the center, which is called radius. That part is clear? You all know area of a circle is nothing but pi r square, where r is the radius and pi is nothing but 22/7. Yeah? Got? So that's why I ask everybody to turn on the videos, because when I make eye contact, it gives me the confidence that okay, if the kids are with me or not. So area of a circle is pi r square, where pi is a constant which is equal to 22/7 and r is nothing but the radius of the circle. Any radius, any circle. Now, Similarly, if you are talking about the perimeter of the circle, if you are talking about perimeter of the circle, you are talking about the entire length of the entire boundary, and that is 2 times 5 times r. Again, same radius, distance from center to the perimeter, and pi is nothing but the same number, 20/7. Yes, Arab?
Would it also be pi times denominator from diameter, but isn't 2 times the pi diameter?
How much value that information adds? That is the question. Now we have not talked about diameter, but even if I talk about diameter, my perimeter is 2 times pi times r, and we know the diameter is nothing but 2 times the radius. So you can say pi times diameter, but I don't want to stress about that. Why? Because first of all, I am not a big fan of memorizing formulas. I don't like memorizing formulas. I rather prefer deriving them myself. So I would never prescribe you guys to memorize 2 formulas. One is perimeter equal to 2 pi r, another is perimeter equal to pi into d. Now if you enjoy doing it, best of luck. I will not prescribe for sure. However, I would still prescribe that there should not be any confusion about the relationship between radius and diameter. Diameter is nothing but 2 times the radius. This is the concept that okay, from the center to any point in the perimeter is radius, and if I extend that in the other direction, the whole length becomes the diameter. Obviously that will be, this is r, this is r, this will be 2r. Now how you relate it, I will leave it for you guys. Is that okay? Dikshita is saying okay with a very, very cold response. Okay. So, anyways, now this is not what we are trying to learn. What we were trying to learn was that what is the area and perimeter for sector in a segment. What is a sector? I will pick up 2 points on the perimeter. If I join these 2 points with the center, this is called sector. Sector of a circle, or piece of a pie, or slice of a pizza, whatever way you want to relate. Is that okay so far, everybody? Now, if you have to find out the sector of the area of the sector of the circle, and if I say this is making 40-degree angle on the center, can you find out the area of the sector? How? Give me the story. I think about it. Yeah, go ahead.
We know like 316 degrees, so
Yes.
if you divide it by 9,
Uh-huh.
you get 40.
Okay, so I will not worry about that. What I will say is, this is 40 degree out of 360. 40 degree of 360. Total 360 was my area. This is 40 of 360 times the area. And that will be 1/9, as you rightly said. I am saying, I will not rely on my calculation skills. I will just say, okay, this is how I will derive it, and then calculate. So finding out area of a sector is not a difficult thing. If somebody says, this is the circle, I have 2 points here which is making an angle of 120 degree, and the radius is, let's say, 10 centimeter. Finding out the area of this sector is not a big deal. It will be same thing, 120 by 360. So 120 out of 360 times the actual area, 5 times r. This is 10 square. So far everybody is okay with me, okay with what I said, right? Sandrine, Sulin. So I am able to see Sulin's face. I am trying to memorize the names correctly, okay? So I said, Sandrine, where's Sulin? And Sulin said, yeah, I'm here. So, okay, I can see both of you now. Okay. So here, when I have to find out the area of sector, that is an easy peasy one. It doesn't stress out, right? Gitesh, are you clear? Finding out area of sector is okay, right? Hiranya, no problem.
Can you repeat it for me? I was getting school.
Okay. One more time. This is a circle. If I say find out the area of the circle, you will say give me the radius. Give me the value of the radius. I will say area equal to pi times radius square. That will be my area. That is okay, right? Now I'm saying I don't want you to find out the area of the entire circle. I don't want you to eat the whole pizza. I'll only give you a part of the pizza, a slice of the pizza. And that slice is big enough, which is making 80-degree angle at the center. Tell me the area of the slice of the pizza or area of this sector that you are seeing here. If you wanted the entire pizza, you were talking about 360 degrees. You are getting only 80 degrees. So 80 out of 360 is what you are getting. Of what? Of the entire pizza. Gitesh, does it make sense? Now everybody with me? Sandin, Sulin with me? Sulin with me? I can see you, Sulin. Sandin, I can see half of her. Okay. Alright. No, it's okay, it's okay. I'm just making it as comfortable for you guys so that you guys don't get stressed with math. Math is not something to be stressed about. Okay? So now, finding out the size of the pizza slice or what you can call a sector is easy. Now, next thing that we have to do is, so sector is fine. If somebody says this is a circle and these 2 points are making an angle of 40 degree on the center and the radius is 15 centimeter, find out the area of the sector. No problem now. You will say 40 by 360 times pi r square. As simple as that. Why it doesn't remain that easy? We have to make it easy. So there is a next thing that is coming to play, that is called segment. Now let's say the same story I am changing a little bit now. I am saying point A and B are making angle 40 degree on the center. Find out the area of this segment. See, if when we talk about sector, we talk about the whole thing from the center all the way to the perimeter. When we are talking about segment, so these are 2 points, I am joining these 2 points and only the area that is below this line, between the perimeter and this line, that is called segment. And that is what we were trying to find out. Okay? So how do we find that out? Conceptually, like some of you told yesterday, that okay, I can find out the area of this sector, no problem. Right? Area of the sector meaning the whole thing. Meaning, I can find out the area of sector which is red and blue together. Which is 40 by 360 here in this case multiplied by pi r square. Life was easy up to here. As long as we were talking about sector. As soon as somebody said no sector, segment, find out the area of segment. So then you say okay fine. What I see here is if I join this point and this point, there is a triangle. The red portion is a triangle. And underneath that there is something. I don't know what exactly to call it. But there is something. So I know the red plus blue area. If I find out the red area and subtract that from, so red plus blue area we know is my sector's area. which is this one. If I subtract from this one, if I subtract red area, then I will get the blue area. Yeah? Then this whole area plus blue minus red, if I do, whatever I get, that is my blue area. This blue area is called segment. Okay? Now, how to find out that blue area is what we were grappling with yesterday. Vasundhara, Hiranya. This is where we left yesterday, correct? I said this is where we left yesterday. Hiranya left now also. Must he'll join back. I'm sure this is a network problem. Okay. So Vasundhara, you're with me, right? Now, this is basically we have to find out the area of this triangle with whatever information we have. Once we find out the area of the triangle, then we'll subtract this area from the total sector's area, and that will be my segment area. Now, how do you find the area of a triangle? If I have a triangle, I have to find out the area of the triangle. What is the formula for that? Half into base into height. Yeah? If I have to find out the area of this red triangle, I need to find out the area of the triangle as half into base into height. That's the formula. I don't know what is the height. I don't know what is the base. How do I find it out? The poor teacher is also stuck now. What to do? If the teacher doesn't know how to do, what would the kids do? Can somebody bail me out? Yes, Gitesh, tell me. Help me. I need some help. I'm stuck.
We need like a side line, one of the sides then.
Now, okay. Side length. This is why I said I love cooking. Meaning, I have to peel off the onions. Hello, Sangeeta. So, Sangeeta, you did not miss anything. We are exactly the same place where we were yesterday when we left. So, and we are talking about the same problem. Let's say there are 2 points here and here on the perimeter. If I connect that with the center, let's say that makes 50 degrees. Okay? And we are trying to find out the area of the segment, which is this shaded area. We know the area of a segment that we can find out, which is red plus blue together, which is nothing but the pie of a pizza. I mean, slice of a pizza. Pie of a pizza. Oh yeah. Slice of a pizza. So, red plus blue together we know. And we are trying to find out how do I find out the area of this red portion. So that from the whole area I will subtract this and I will get the area of the segment. Okay? That's where we were, Sangeeta, right? You remember?
Yes.
Okay. So, before we go with our adventure to find out this area, there are certain concepts that I want you guys to brush up. That will make your life much easier. So, whatever we talked about with respect to sector or segment, I am parting it right now. Because I want you guys to cover or catch up on certain concepts of Pythagorean theorem as well as basic trigonometry. So, cut off. Okay? And then we'll come back to this guy and then this will become much more easier for us. Okay? So, Pythagorean theorem. What does it do? Spend few more months with me. You'll become better with storytelling. I want all my kids to become better with storytelling. Meaning, a square plus b square equal to c square, that's the exact formula. There's nothing wrong with that. That's a perfect formula. But when you're explaining that to somebody, you will say Pythagorean theorem is a concept relating to a right angle triangle which says the two sides making 90 degree. You don't have to write it down, it's okay. You have it in the video. Don't worry about it. So I always say, don't be busy taking notes, okay? It's all a concept. So Pythagorean theorem is a concept relating to right angle triangle which says the two sides making 90 degree. If you take square of both the sides and add them together, that will be equal to the square of the hypotenuse. And this story is not something that I have memorized. I made it up while I was talking. So same thing. This is right angle triangle, and these are the two sides making 90 degree, A and B. And this is the side which is opposite to that 90 degree, which is called hypotenuse. So Pythagorean theorem says, in a right angle triangle, the two sides that are making 90 degree angle, the square of sum of the square of both the sides is equal to the square of the hypotenuse. So a square plus b square equal to c square, that was the simplest form to remember for sure. There is no simpler way to remember this. I just made it look a little more fancy by giving a definition to it. Meaning, if you are talking to, let's say, 6th grader or 5th grader or 4th grader, and you have to explain him or her what is the Pythagorean theorem. For sure, a 5th grader would know what is a right angle triangle. He or she will know that a right angle triangle is a triangle where one of the angles is 90 degrees. Like what the 5th grader would know. And you are trying to enable or enrich that kid's knowledge by saying, okay, you know what? When you guys grow up, this is what will come across. Right angle triangle you already know. This Pythagorean theorem says how you can relate the sides. Interesting or boring story? Yep. Is everybody with me? That story is okay? Pythagorean theorem story? Okay. So this part you guys know. So if I decode that a little bit, you see that this is one side and this is the other side, and this is the hypotenuse, meaning the side that is opposite to the 90 degree is called hypotenuse. These two are just the two adjacent sides. Let's keep this information handy with us. Now, and how this formula is derived, that I will explain in coming weeks, months. Okay, I've done it already once. There is a way to derive it. Okay? It's very easy. But there is one more related concept which is on trigonometry that we'll look at right now. Same thing. SOHCAHTOA. This is 90 degree. Let's say this angle is something. I don't know what it is. I'm calling theta. This is A, this is B, and this is C. Yep. Who remembers what is sin theta here? R.A. Wadlik will say, yes, I have heard from you guys. I want to give chance to everybody else. R.A. Wadlik, I have heard from you guys. I know you guys know what is SOHCAHTOA, so I will not let you repeat it. Anybody else? No? What is sin theta? So, okay. This is one more segment of math which is called trigonometry. Okay? If you have not come across trigonometry before, that's okay. We are starting it now. So trigonometry is nothing but another way of dealing with a right angle triangle. It tells you a different approach. How would you relate the sides using the angles? Okay? So like Pythagorean theorem says, okay, how do you relate the sides in a right angle triangle? Here, trigonometry gives you another ability to relate the sides and angles together. Now, it says, okay, sin theta. If let's say this is 90 degree, I am calling this angle as theta. Sin theta will be equal to the side opposite to that divided by hypotenuse. Likewise, cos theta will be equal to, this is theta, this is the opposite side, this is adjacent side. Cos theta will be equal to B by C. And tan theta would be equal to A by B. So here what you are seeing is, there is an angle and that angle relates to these sides. If I have to relate this side and this side, I can relate with this angle. If I have to relate with this side and this side, I will use cos theta to relate them. If I have to relate this side and this side, I will use tan theta to relate them. So this is another, in the simplest form, sine, cos and tan theta or trigonometry is another way of relating the sides and angles of a right angle triangle. Very simple, okay? Doesn't sound simple? Okay, so then, ka tuo. Do you remember this?
I know what it is, I just forgot what it stands for.
Right. So SOHCAHTOA is your building block of trigonometry that says if in a right angle triangle, how to relate the sides in trigonometry terms. S stands for sine. Sine, look at this, sine theta. Sine of theta is opposite side divided by, it's SOH. Opposite side divided by hypotenuse. Theta is here, opposite side divided by hypotenuse. This is sine theta. This one is cos, C stands for cos theta, is adjacent side. This is a theta, this is adjacent side divided by hypotenuse. Adjacent side by hypotenuse. Adjacent side is B by hypotenuse, which is C. And TOA, T stands for tan theta. Tan theta equal to opposite side by adjacent side. Okay? Adri, Kara, did I explain it okay? The way you guys knew it? Okay. So, now you guys must be thinking that, okay, we came to this class to make life a little easier. It's getting complicated. Is it? Okay. So I'll tell you why we are going to this dimension of things. Forget about SOHCAHTOA, sine, cos, tan, trigonometry, algebra, geometry. Look at this as an opportunity for getting more information. When we are trying to solve a problem, right? When you are trying to solve a math, what do you need for solving it? Maximum information. If I say find out the area of the triangle where this side is 2, what will you do with that? That's useless. Because you know that you need half into base into height. What is base? If I call this as a base, where is the height? Nobody has given that to you. So for solving any problem, you need information. You need details to be able to solve it. Same way here, we learn Pythagorean theorem that said, okay, what is the relationship between the three sides in a right angle triangle? When we are learning trigonometry, it is not to make our life complicated. It gives us another avenue for extracting more information or the relationship between the different elements of the triangle. Is it making sense, Sandra Zulin? Yeah? Sangeeta with me? Hiranya with me? Vasundhara with me? Arav Advik with daddy, mommy at home? No, I'm just sitting, okay? Everybody's with parents only. I'm just asking, just waking up everybody, making sure that whatever I'm saying, Dikshita, no confusion, right, Beta? Okay. So, in summary, you will say that, okay, there is so much of a distraction. We starting from one place, going all over the place. That is because there are a lot of things which are related. So, if you remember, we started with the circle, we talked about area, perimeter, then we talked about sector, then we tried to find out the segment. And before I try finding out the segment, I wanted to give you guys some more information, some more ability to extract more information from this so that we can use that for finding out details. Yeah? So in that, while making that attempt, we said, okay, fine. What else did we learn? Or what else do we know? Okay, we have one silver bullet, magic wand, called Pythagorean theorem. What does it do? It only deals with right angle triangle, which says if you have two sides making 90 degree, square, sum of the square of the two sides making 90 degree will be equal to the square of hypotenuse. This is first information. Second one is we just explored little bit of trigonometry, and trigonometry is a full-blown subject by itself. We are not going to depth of that. We are just going to use as much as we need it right now. Okay? Yeah? Everybody with me? Everybody equally selfish as I am right now. I'm not going to depth of trigonometry. I'm only focusing on what we need right now. So trigonometry says ca to sine cos tan, and this is 90 degree, this is a right angle triangle, this is A, this is B, and this is C, like what you see here. We are just adding one more dimension to it. If you look at a triangle, triangle has 6 things, 3 sides and 3 angles. Those are the building blocks to make a triangle, right? So here we are dealing with only sides. So this is not complete by itself. So trigonometry gives us a little more ability, so you have to find how you can relate the sides and angles together. Okay? So here we got, let's say if I say this angle is theta, I don't know what is the value of theta, maybe 15 degree, maybe 60 degree, maybe 120 degree. Is that possible? No, right? Can theta be 120 degree here by any chance? No, right? Okay, I was seeing 2 fingers glued on the screen like this. I was wondering what's happening with Ajay. Okay, so coming back to this one, I was just asking that this angle can be 10 degree, 20 degree, 50 degree, but nothing more than 90 for sure, because I have 90 already here. I cannot have another angle which is 90 or more. So anyway, so I have, let's say this is theta for now, and trigonometry basic building block says this is the relationship. There is nothing to prove here. It says we are giving it a name. That if this is theta, sine theta is opposite side, which is A, by hypotenuse, which is C, or A by C. Cos theta, that's another name given by trigonometry, saying cos theta is adjacent side. So this is theta, adjacent side to that is B, divided by hypotenuse, which is C. And then tan theta is opposite side, which is opposite to the angle A, divided by adjacent side, which is B. So these are 3 names given, okay? Like if you say, if somebody says, what is the name of your math teacher? You will say Virendra Kumar. What is the name of your science teacher? You have a science teacher, you will know the name of that person, right? Similarly, there are 3 teachers. There are 3 names given, okay? That this ratio will be called sin theta, this ratio will be called cos theta, this ratio will be called tan theta. In trigonometric terms. Is that okay? Everybody okay with that?
Yes, sir.
Okay. So, we learned this part. Now you will say, why we are doing it. Let me give you guys a little bit more clue now. Coming back to the same problem from where we had started. Now let's say this is 60 degree. There is another thing that we talked about yesterday, that if I drop a perpendicular from here to here, if this is 60 degree, then these 2 angles are also 60 degree. Sure? Because? Tell me why. It's an equilateral triangle eventually, because this is 60 degree. Even if this is not equilateral triangle, let's assume for now this is not. So what happens is, even if it's not equilateral, this is isosceles for sure, because these 2 are radiuses. So this angle and this angle will be same. So 180 minus 60, then you left with 120 and that is divided equally. So that both become 60, 60. So now everything is 60, so that is equal that. And what we were seeing yesterday was, if I drop a perpendicular from here to here, I will get two triangles. Let's say this is A, B and this is C. I drop a perpendicular from here to here. This is D. Then this side and this side will be equal. Why? Anybody on the screen? Yes, Advait.
Because if you put the perpendicular line in the middle, it's going to be symmetrical.
That is not convincing. Give me a mathematical answer. Yes, Gitesh.
Yesterday we talked about the four geometric symmetrical. I don't know.
That is called theorem of congruence.
I can't say. Side, and side. What's this?
Okay.
Angle, side, angle, and then RHS.
Yeah.
You can do RHS for this. But
Right.
in this one.
Right. No, I'm very impressed. You remembered what we discussed briefly. So, again, I'll explain that to the kids who were not in the class yesterday. So, again, I'm just coming back to this one. I will again go back to what I was discussing with Gitesh. But here, now by Pythagorean theorem, this is not helping right now. Okay, we are ultimately trying to find out the area of this triangle. Right? And how do we find out? We have to find out the base and then the height. That's why we drop the perpendicular. By dropping the perpendicular, it's okay to drop, but we don't know what is the length of this height. I mean, what is the length of this side and what is the length of this side. That's what we are trying to derive. So we'll go deeper into that. That's what we are discussing. So actually, let's say after doing all the magic, if we find out the length of this side and we find out the length of this perpendicular this thing, then we have the base and the height. From that we'll be able to find out the area, and we'll subtract that from this whole area of the sector. That will give you the area of the segment. That's what we're trying to do. So it's like we are moving a mountain for feeding an elephant. Yep. But what to do? There is no choice. But good thing is, while moving the mountain or just in an attempt to feed this elephant, you are recalling Pythagorean theorem, you are recalling trigonometry, and you are getting into the nitty-gritties of geometry, where we talk about theorem of congruence, which we will come to now. So we talked about Pythagorean theorem, we talked about trigonometry, basic trigonometry concepts. Now we will come back to the theorem of congruence. Is that okay for everybody? Or now everybody is scratching their head? My humble request to you all, don't scratch your head too much, otherwise you will lose hair like me. Yeah? I don't want you guys to lose hair at a very early age. Okay. So jokes apart, dad joke, bad joke, keep it aside. Let's come back to theorem of congruence. Is that AC working for you guys? Is it comfortable? Okay, let me move that little further so that I also get a little bit of that. I will keep it a little away from cavity because she is little cold, right, Beta? Are you okay? Okay. But you're fine, right? If the AC is little closer, it doesn't hurt, right? I'll get it up. Okay. Now, yes, Sarvita.
To find the height, are we also allowed to use the 30, 90, 60 trick that we learned yesterday?
Yes. So, see, we will come to that also. Ultimately, what is the goal? The goal is to have as many options as many simpler options, and all the knowledge combined together so that at one time we can choose whichever clicks, whichever sounds, or whichever resonates very quickly during the exam or whenever we are trying to solve the problem. Now, let's come back to this one. I have two triangles. I am saying, right now we are going to touch upon the theorem of congruence. What do you mean by congruence? Anybody? Real good.
When it's exactly the same.
Yeah, Gitesh.
That two shapes are equal. Like
Yeah.
everything
That-
area and
Everything the same, a photocopy of each other. Yeah? I am thankful to God. My hands are congruent. Yeah? Imagine if they were not the same. That would have been a problem. Right? I mean, no joke against people who eventually have that problem. But just from a concept point of view. When I'm saying congruent, I'm saying exactly the same. No, don't check. Don't. I'm not trying to make you guys think about something which doesn't really make sense. Okay, that's not even important. We are thankfully everybody is healthy, fine, fit. Okay, don't worry about it. Now, in simple terms, when you say congruence, we are talking about two things being exactly the same. If I say this and this triangle are congruent, I am saying that they are photocopy of each other. Interestingly, my drawing skills are horrendous. That's why you don't see them looking exactly the same. But I am making you guys believe that they are congruent. So when I say they are congruent, what I am essentially saying is they have every property matching. Does it make sense, Sandrine and Sulaim? Yeah. So if I say this triangle and this rectangle is congruent, these two are congruent, you will say, sir, you need to take a break. You are probably exhausted. A triangle and a rectangle cannot be congruent. Okay? They have no reason for being congruent. Okay? No ability for being congruent. So meaning they have to have similar shape in the first place, and then they have to have matching properties. So this side and this side matching. Okay, we still have a hope. This side matching. There is a hope still. This side and this side also matching. Yeah, seems possible. Now this angle matching. We are very close to being congruent. This angle and this angle are matching. We are much closer to being congruent. Now this angle and this angle also matched. Now each and every property matched. There is zero doubt. But do we always have to match each and every property of two triangles to make them congruent? No. It gives us ability based on some relationship that those are called theorems. We don't really have to, see, math is a very friendly subject that has no intent of getting us stressed out. It says, even if you know that two triangles will be congruent if all the properties match, but don't worry, there's some relaxation for you guys. Relaxation is, don't have to match everything. If you have three sides matching, you're good. If you have two triangles, where only the three sides match, don't worry about that, they will match by default. You don't have to worry about it. Isn't that a big relief? Out of 6, we are matching only 3. Okay? And we will prove that in future classes, don't worry about it. So, that is one theorem which says you don't have to verify all the properties. Only 3 sides matching, you are good. And then you can assume that everything else will match. This is the theorem of congruence. First theorem of congruence called side, side, side. S. S stands for side, A stands for angle. If the 3 sides are matching, they are congruent. Now, second one says, if you have 2 triangles where 2 of the angles are matching, meaning let's say this angle and this angle matched, this angle and this angle matched, and the side between them also matched. then you can assume everything else will match your point. Yep. And we will prove that in future classes, don't worry about it. For now, I mean, there is no need for proving it, but as I always insist, that don't rely on any information that comes to you just as is. Don't take anything on the face value. Ask questions, okay, why ASA is enough? How about the remaining three properties? That's what will come to. Now, in today's class we not, but in future class yes. Third situation is, or third theorem is, when you have two sides of two triangles matching, meaning let's say this side and this side match, and this side and this side match, and the angle between them, this and this also matched, then they are congruent. This is the third theorem of congruence. Is everybody with me? Am I making anybody feel sleepy? No? I have not been successful then. Okay, I was trying my best to make you guys feel sleepy and call it a day early. Okay, fourth one is actually for right angle triangle. That's what it stands for. See, everywhere we're talking about S as side, A as angle. See, here everything is different. Only one side is there. So R stands for right angle triangle and H stands for hypotenuse. So this is a theorem which is dedicated for only one type of triangle, which is right angle triangle. So you use this theorem for right angle triangle only for congruence. So these three theorems that you saw here, that is applicable for each and every type of triangle. Okay? Wherein this one is specific to right angle triangle, which says that two right angle triangles, let's say this one and this one, will be congruent if the hypotenuse match, meaning this one match. This is hypotenuse, right? As you can see, hypotenuse is always the largest side of the triangle. Okay? So, largest side of the right angle triangle. So, if the hypotenuse match and one of the side match. So, there is no bias. If this side matches, that's one okay. If this side matches, that's also. Now the teacher is feeling sleepy. Do I look sleepy? No ways. There are three times when I don't feel sleepy at all. One is when I'm teaching math, second when I'm driving a car, third when I'm flying. I cannot sleep in the flight as well. It feels like there's a lot of stress on my shoulder. If the plane, there's a turbulence, it's my responsibility to bring it back to control. That's how I feel. So there are three situations when I don't feel sleepy. When I'm teaching math, I will not feel sleepy. So even if I'm joking, take it easy. So here, these four theorems of congruence about triangle is what we need to know. Adrik, I would suggest you sitting down, even if you feel sleepy. In the class, I would not entertain or expect or assume anybody to lie down. We are not on a beach right now. So here, there are four theorems of congruence. First three theorems says side, 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 or angle, side, angle, side, angle, side. So either all sides or a combination of two angles and a side or two sides and angle. That's how you read it. And this fourth one is specific to the right angle triangle, as the name says. R stands for right angle triangle. And then if the two right angle triangles would be congruent if the hypotenuse matches, meaning this one matches, and one of the side, any one side, be it this one, or this one, perfectly fine. Now I'm going to disclose the $1 million secret for why we were doing this. Now we go back to the same problem where I was talking about a triangle. Let's say, now I'm just taking a picture of what we had inside the circle. I have this as 60 degree, this as 60 degree, this as 60 degree, meaning this is an equilateral triangle. Let's say this is 10 centimeter. Then this will be 10 centimeter, this will be 10 centimeter. Yeah? if I have to find out the area of this triangle, what will that be? I need the base and the height. I have the base, I don't have the height yet. Okay? So let's find out the height. I draw the perpendicular, this is the height. I don't know the value of this guy though. Okay, I draw the perpendicular, this is 90 degree. Now, if by some means I find out this guy's height, then just how will I do that? Now, look at this. Let's say this is my A, B, and C. We don't know this height, this length yet. But I can say this is 5 centimeter. And this is also 5 centimeter. You will say why? Because I was telling you guys about the theorem of congruence. I have dropped a perpendicular, meaning I have split this triangle into two right angle triangles now. Let's say this is D. So I have one triangle A, B, D. This one, the one in blue. And I have another triangle ABD is in blue. Let me play with the color a little bit. And then I have other triangle ACD, which is in red. Yeah? Are you with me? I have two triangles, one blue, one red. How do I get this? How did I get these two triangles? By dropping a perpendicular from here to here, in the case of an equilateral triangle. And when I did that, I split that into two right angle triangles. And I am saying they are congruent actually. Why? Because this is equilateral. This side same. These two sides are same for the larger triangle. But these are the hypotenuse of the two right angle triangles that we have converted it to. So the hypotenuse are matching. This side is anyway common in both the triangles. So right angle triangle are congruent if the hypotenuse are matching and one other side is matching. That one side is common between both of them. That means these two triangles are congruent. I can safely say this side and this side is equal. That is how 10 became two equal sides, combination of two equal sides. Both are 5 centimeters. I want to see everybody's face and want to read your reaction. So why I want to see everybody's face? Because I want to know if whatever I explain is that sounding clear, convincing to everybody or not. Sanvita, is it clear beta? Vasundhara? Hiranya? Sanjan, Sulit, okay? So, summary of that is, I had an equilateral triangle and my struggle was how do I find out the base and the height so that I can find out the overall area. What I did was, okay, fine, to find out the height, I have to drop a perpendicular. As soon as I dropped a perpendicular, I saw that it split that into two equal or congruent right angle triangles, applying this theorem of congruence. So now, what happened because of that is, I found this height, this distance is 5. I know this distance is 10. I should be able to find out this one with the help of Pythagoras' uncle. What did Pythagoras' uncle say? You have a right angle triangle. If this is B, this is A, this is C. A square plus B square equal to C square in case of a right angle triangle. If you look at this right angle triangle, you know this one is 5, so your B is 5. Your C is 10. You don't know A, but that's okay. A square equal to B. B is this one, 5 square. A square plus 5 square equal to C square. C is 10. 10 square. What do you have? A square equal to 10 square is 100. And this goes to this side becomes minus. Minus 5 square. 5 square is 25. So A square is 75. A is square root of 75. Whatever it be. Yeah? So what happened? with all that drama, circus, juggling that we were doing so far, somehow we were able to find out the base and this height. So I can find out so we were able to find out this base any which way, but by using this small right angle triangle we could find out the height also using the Pythagorean theorem. Now I can take the whole thing as a base and this is a height and find out the area of this triangle. What does it mean? So, math is a very related concept. Now let's look at the whole journey. And I don't want you guys to get stressed out for solving this problem. I want you guys to understand and appreciate the approach that we took. How did we break down this whole thing to find how did we move the whole mountain to feed the goat this time, not the elephant even. Okay? Now, what we were trying to do? We were trying to find out the segment of a circle. Meaning, there are 2 points A and B. If I join them directly, I was trying to find out this one. And we had no ways to do it. The only thing that we knew was how to find out this circle. The whole thing. Meaning, red and blue together. Now I'm wanting you guys to digest this story, okay, rather than being worried about the concept or mathematical part of it. So when we have to find out this segment, the red portion, we did not have a straight or direct a way to do it. What we had was we knew that okay, red plus blue together we can find out. That's why if I have the angle known to me and the radius known to me, I can find out red plus blue together. Now we were trying to do, okay, if I have to find out only the red part, that means red plus blue minus blue I will do to get the red. Red plus blue minus blue will get me only red. This one. So to get to that, we have to first find out what is the area of this car. So we had this is known, these 2 radiuses are known. We picked up a question where we had this angle is 60 degrees, so it became an equilateral triangle, and then we dropped the perpendicular. So to find out the area of this triangle, we had to find out the base and height. So we found the base using the geometry concept. This is 60, so this is 60, this is 60. So this is same as this or this. So we found out that okay, all the 3 sides are same. This radius, this is also radius. This is 60, this is 60, this is 60. So then we found the base. Now the problem was to find out the height. So to find the height, we dropped the perpendicular. And then we saw this whole triangle splitting into 2 triangles, 2 right angle triangles. So from that we can find out the height. So when we split this into 2 right angle triangles, we found they are both congruent. Meaning I can find out this base. If I find this base, then apply Pythagorean theorem to find out this height. Now I have the height, I have the whole base, I can find out the area. And this area I subtracted from red plus blue and got the area of the circle. That was the whole journey. And it was stressful. It was stressful because we had to put a lot of concepts together. This was a very poor, simple question saying, okay, I have a very cute looking circle, find out the area of this thing. Imagine how much intense it was to get this part. You had to figure out geometry concepts, you had to apply Pythagorean theorem, and good that we dealt with 60 degree alone. If it was not 60 degree, it was 50 degree, that is when we would have dealt with trigonometry that we talked about so far over. Because this gives you the ability to relate the sides and the angles. Here, just because we could find out this base, it was easy for us. But then, if this is 50 degree, then this is what? This will be 65 and 65. Now you don't know the length of this base. You only know the angles. So you know the angles and you know what are the sides. That is where you will use trigonometry concept to find out the remaining 2 sides and then apply that for solving to find out the area of this triangle. Time to breathe. Is it clear to everybody? Everybody. again, these are, trust me, you guys are well ahead of your grade now. These concepts will not be coming to you as easy or as a natural thing, okay? Because I have seen, when I was teaching my own elder daughter, I realized that they don't touch upon these concepts. They don't relate a lot of things together. They'll give you a formula, say apply. But then if there's a little twist in the question, that is where, if you know the concepts well, if you know how to connect the dots, it makes your job much easier. I was thinking like this. I'm seeing 20 emojis flying simultaneously. What does it mean to me? Okay. But a serious question to everybody. Were you able to relate what we were doing? Yeah? If there's something, see, I would never claim that I'm the best teacher. I don't think so. So that's why I'm making my life a little easier by recording it. Because what happens is, when somebody explains something, right, and you hear me, you'll probably think that you understood it. But when you try to do it yourself, you might get stuck somewhere. That is where this video will help. So if there's something that was not clear to you guys, it's very natural. It's perfectly fine. You guys don't have the luxury of getting beaten by your parents. Okay? When I was small, every weekend when my dad will come, he will give me 2 sums to solve, and then I will start thinking about the consequences. And interestingly, those consequences used to do magic. Okay? Those consequences will do magic. But then going through the consequences was not fun. So here, let's not think about past. That is all history. What I'm saying is, for you guys, don't think of that as an option. The option that you guys have is, if there's something confusing, watch the video one more time and try doing it. When you try doing it, you'll come across some roadblocks, you will get stuck. Again, watch it one more time, see, okay, where did I miss it? Did I do it well? And then, when you do a couple of iterations, then you will realize that now you're able to relate. So my way of learning is historical, ancient times. For you guys, it's different. Don't think of relating these two generations together. But yeah, we'll try doing it. Okay, more with fun, less with stress. And don't tell anybody, okay, it is going to go to YouTube, so this will become public, but this is normal, it's okay. Okay? As long as I'm not doing anything bad, I'm still safe. Alright guys, so have fun. See you guys next Saturday. I'll upload the video of the class after some time. Whatever you got stuck with, watch it a couple of times, you will be clear. And once you're clear, enjoy it, pick up some problems, try solving it by yourself. I'll give you guys some assignment. I would want you guys to try. It's okay to fail. It's okay to not be able to solve it in one go, but it's not okay to not try. Okay? Yeah? Alright. Have fun. See you guys next Saturday. Yeah? Take care.
Bye, sir.
Bye-bye. Bye-bye.
Bye, sir.
Bye-bye. Bye-bye. Okay.